This presentation provides a technical overview of VMware vSAN up to and including vSAN 7 Update 2. VMware gives the customer the power of choice, and this continues into the hybrid cloud era. The evolution of vSphere and vSAN now means that it can be the platform of management for today's business-critical applications, as well as cloud-native applications. Data centers powered by VMware vSAN offer scalability, flexibility, and manageability to meet nearly any demand, and is the cornerstone for customers looking to build a multi-cloud solution powering existing and next-generation applications. How organizations provide services to support their customers and business processes is changing rapidly. Not only are applications changing, but so are the options in how and where to best provide those services. Should it be on-premises, in the cloud, or both? The industry is demonstrating that the combination of the two serves the most use cases. But how does one create a combination of the two using a common set of tools? This hybrid cloud can be achieved with VMware. Let's see how. Hybrid cloud means interoperability, agility, and efficiency. We believe there are distinct steps in this journey to building a true hybrid cloud. The first step has been achieved by most, as they've already experienced the benefit of virtualizing the majority of their workloads. The use of public cloud may also be a key part of your organizational needs. Workloads in public clouds often become another silo to manage, and typically is not integrated with any on-premises management tools or methods. Data centers are complex, and the cloud adds to this complexity. The next step is to modernize your infrastructure through Hyper Convergence with vSAN, then add networking and advanced management capabilities with NSX and vRealize. Finally, extend your SDDC to public cloud and the edge to adopt a true hybrid cloud architecture. This approach abstracts operational differences away from where the workloads will be running, and provides a common control and management plane to give administrators the agility in delivering services to their businesses. A hyper-converged architecture can remove dependencies from hardware feature sets. By abstracting these features away from the underlying hardware, you can address and apply the right settings in the right way for each workload running in a data center. As organizations are looking for interoperability with other public or private cloud environments, being able to apply these settings in a granular way using software is quickly turning into a requirement. Full-stack HCI can be achieved through VMware Cloud Foundation when powered by vSAN. So why is hyperconverged through VCF better than traditional approaches? Simple. The end-to-end solution that a vSAN-powered VCF environment provides improves on three pillars of data center management: deployment, operation, and optimization. Data centers are not static. As demands of the applications and the users that need them evolve, so should the environment that powers it. Historically, this has been difficult. This new approach transforms the challenges of legacy architectures so that the deployment is fast and tailored to an organization. Operations can be performed in an outcome-oriented manner through the use of policies. The value of a solution comes from far more than just how fast it is to deploy. Ongoing changes are the norm for a data center. VMware's approach follows a maxim often used in the world of fast-paced software development: design as if you know it's going to change. First, let's quickly review what VMware offers. VMware's platform offers the levels of flexibility required for today's rapidly changing needs. It's built off of a foundation of VMware vSphere paired with vSAN. This provides the basis for a fully software-defined storage and virtualization platform that removes dependencies from legacy solutions using physical hardware. Next is VMware Cloud Foundation, the integrated solution that provides the full stack of tools for an automated private cloud. And finally, there's VMware Solutions for the Public Cloud. VMware has partnered with industry-leading cloud providers that offer services based on VMware Cloud Foundation. This offers customers to build a hybrid cloud with public and private assets, using a common substrate of management and tools for consistent infrastructure operations. Public cloud partners include VMware Cloud on AWS, Azure VMware Solutions, Google Cloud VMware Solutions, IBM VMware Solutions, and VMware Cloud Provider Partners. A true hybrid cloud architecture consists of software technologies that allow virtualized workloads independence from their physical location, whether it be the core data center, the edge, or the cloud. Next, a control and management plane has to provide a consistent management experience so that users can focus on a desired outcome instead of management nuances of a siloed data center. From there, common tools can be used across the digital foundation that enable organizations to better respond to their needs, and do so with consistency and confidence. The power of choice is extended to how vSAN can be consumed by the customer. Let's take a look at what those options are. The power of VMware's SDDC stack becomes evident when we look at the multiple consumption models available. A customer may be familiar with an on-premises consumption model such as VMware Cloud Foundation or VCF. From there, an organization may like the appeal of a cloud subscription model, but have requirements to keep the hardware on-premises. This is where VMware Cloud on Dell EMC comes into play. This is an all-inclusive service that is jointly owned and operated by VMware and a hardware partner that eliminates hardware or software asset ownership. Or a customer might like the elasticity of extending their environment by using a public cloud partner. Public cloud partners include VMware Cloud on AWS, Azure VMware Solutions, Google Cloud VMware Solutions, IBM VMware Solutions, and VMware Cloud Provider partners. In on-premises environments where a customer will be utilizing purchased hardware and software, the way that vSAN is delivered to a customer is dependent on whatever suits their needs best. This is why the power of choice is important. Some want to simplify purchasing, deployment, and management with single SKUs, and this is where VxRail comes into play. Others may have a preference over server vendor and would like to maintain that consistency as they adopt vSAN. This is where vSAN Ready Notes can be a good option. These consumption models are a great set of choices that fit the needs of the organization in the best way possible. Let's take a look at how and why VMware vSAN is the common substrate for a hybrid cloud environment. vSAN is VMware's software-defined storage solution built from the ground up for vSphere virtual machines. It abstracts and aggregates locally attached disks in a vSphere cluster to create a storage solution that can be provisioned and managed from vCenter. vSAN is built inside the hypervisor. It integrates with the entire VMware stack, including features like vMotion, HA, and DRS. VMware storage provisioning and day-to-day management of storage SLAs can all be controlled through VM-level policies that can be set and modified on the fly. vSAN delivers enterprise-class features, scale, and performance, making it the ideal storage platform for VMs. The efficiency in delivering storage is one of the true secrets behind the power of vSAN. This tremendous efficiency means that vSAN can run more VMs per host than any other HCI system, not integrated into the hypervisor, and with much more consistent levels of performance. This ability to scale up and out means that users can strategically design their vSAN-powered cluster to accommodate growth that best reflects the needs of their organization. VMware vSAN uses a data placement approach that is most analogous to an object store. VMs that live on vSAN storage are comprised of a number of storage objects, which can be thought of as a unit of data. This data is placed across hosts in the cluster to ensure resiliency. What makes vSAN so powerful is that the administrator simply applies a storage policy to one or many VMs that define the outcome, or the desired level of resilience, and vSAN takes care of the rest. In the example shown here, we see a VM with an associated storage policy of a level of failures to tolerate equaling 1 using RAID 1 data mirroring technique. This creates 2 copies of data and a tiny piece of metadata on a third host known as a witness component. The witness simply helps vSAN determine availability during failure conditions. With this object-based approach to storage, vSAN determines the placement of data based on the assigned storage policy. Whether the cluster has 3 hosts or 30 hosts, the policy defines what the desired result is and will place and manage the data to ensure the adherence to that policy. vSAN offers a number of data services. These are features or capabilities that can be enabled or disabled on a per-cluster basis. Since vSAN provides storage as a resource of the cluster, this can make it easy to tailor cluster configurations to meet the precise requirements of your organization. When these data services are enabled or disabled, vSAN takes care of the entire process required to achieve the new settings. This makes prescriptive configuration settings quite easy. vCenter Server provides for easy configuration of vSAN, as well as ongoing monitoring and adjustments. In the vCenter Server UI, you'll find 2 primary areas for all things related to vSAN: the Configure tab and the Monitor tab. The Configure tab is where the data services for the cluster are configured, as well as the use of host storage devices. It's also where configurations can be made to accommodate different types of topologies. The Monitor tab is where one can see all ongoing operations with vSAN: health, performance, data placement, and capacity. For vCenter administrators, vSAN may be new to you, but the experience will feel easy because you're using software that you already know. Now let's take a look at how vSAN simplifies the management experience of running on-premises, in the cloud, or running in a hybrid cloud. Doesn't it make sense to control storage resources on a per VM basis in the hypervisor, just as you do for CPU and memory? Traditional storage solutions simply couldn't offer this level of control and were limited to providing one-size-fits-all approaches to storage performance and protection. This is where VMware's storage policy-based management comes into play. Levels of protection and performance are no longer reliant upon the capabilities of an external storage system, but will now be controlled and managed by the hypervisor. A user defines the outcome desired and applies it to a VM, VMDK, first-class disk for container persistent volumes, and even file shares powered by vSAN file services. All of it managed easily inside of vCenter. Storage Policy-Based Management, or SPBM, is extremely easy to implement. Creating a storage policy is nothing more than defining what your requirements are for a VM or a collection of VMs. These requirements are typically around protection and performance of the VM. A new policy can be created in vCenter and accessible for use by any VM managed by the vCenter server. Once the SPBM policy is created, the policy can quickly be applied to a VM. The VM will adopt the new performance and protection settings without any downtime. One can change the characteristics of an existing policy, and the VM will adopt the most recent settings of the policy without any downtime. These policies can be applied to VMDKs, VMs, first-class disks for containers, and file shares served up by the vSAN file services. SPBM is about ease and agility. Traditional architectural models relied heavily on the capabilities of an independent storage system in order to meet the protection and performance requirements of workloads. Unfortunately, the traditional model was overly restrictive in part because standalone hardware-based storage solutions were not VM-aware and were limited in their abilities to unique settings to various workloads. Storage policy-based management lets you define requirements for VMs or collection of VMs. This SPBM framework is the same framework used for storage arrays supporting vVols. Therefore, a common approach to managing and protecting data can be employed regardless of the backing storage. In addition to a traditional vSAN cluster, the power of vSAN also extends to its capabilities in supporting different types of topologies. vSAN uses the concept of fault domains to protect an environment spanning two physical sites from downtime in the event of a site failure. vSAN's ability to provide a fully active-active stretch cluster has already proven its value in data centers. vSAN provides the capability for storage redundancy within a site and across sites at the same time. This helps deliver effective, affordable protection against site outages, as well as host outages within a site. This level of protection is extraordinary and what many of our customers have asked for. Lower TCO is the result of no need to purchase additional hardware or software while addressing protection requirements with software you already know. Remote offices and branch offices, or ROBO, is a common geographic model for many organizations. vSAN typically requires a minimum of 3 hosts to run. There is, however, a special 2-node configuration, making it easy to run a 2-node vSAN cluster to provide all the storage needs in these branch offices, while using the primary site as the location to house the witness appliances. This makes for a fast, affordable, and flexible management and delivery of services in environments that requires this type of topology. Additionally, vSAN Robo licensing has no host limit restriction. However, a maximum of 25 VMs can be run in a single site or across sites. Any multiple of 25 requires an additional 25 VM pack license. Lastly, there is no upgrade path from vSAN Robo licenses to regular CPU or desktop vSAN licenses. Fault domains are a boundary of failure. vSAN extends this concept of fault domains so that environments can protect against failures such as a rack failure. It gives the administrator the ability to, 1, determine what the logical boundary of failure should be, like a server or a rack, and 2, define a logical container that represents that boundary in the cluster. The most common way fault domains are employed are by creating a fault domain that represents a rack in a data center, as shown here. The vSAN data would be distributed across multiple fault domains so that in the event of a total rack failure, no system would be compromised. VMware HCI Mesh is vSAN's all-new feature that provides for disaggregated HCI, or DHCI, exclusively through software. HCI Mesh allows for an administrator to easily define a relationship between two vSAN clusters and borrow capacity from another cluster, improving the agility and efficiency in an environment. This disaggregation allows the administrator to separate compute from storage. HCI Mesh uses vSAN's native protocols for optimal efficiency and interoperability between clusters. Complementing the inherent capability within vSAN to treat storage as an exclusive resource of the cluster, HCI Mesh delivers the flexibility and resource provisioning that many of our customers have been asking for. VMware introduces a significant new capability to vSAN HCI Mesh. In vSAN 7 Update 2, traditional vSphere clusters can mount a remote vSAN data store. HCI Mesh compute clusters can consume storage resources provided by a remote vSAN cluster, in the same way that a traditional storage array can be connected to multiple vSphere clusters. HCI Mesh Compute uses native vSAN protocols for maximum efficiency and affords the customer the ability to easily meet a broad variety of use cases. Most importantly, HCI Mesh Compute clusters do not need any vSAN licensing. Scalability has also been improved, where the number of hosts connecting to a remote vSAN data store has been increased to 128. One of the most interesting capabilities as it relates to HCI Mesh are the integrations with storage policies. When defining a storage policy, an administrator will be able to define the types of data services that they're interested in, such as deduplication and compression or data at rest encryption, and the storage policy wizard will filter out the available data stores that meet the criteria. This allows for an easy understanding of what type of storage may be available to multiple vSAN clusters connected by HCI Mesh. Flexibility and efficiency are two of vSAN's strengths. This flexibility and efficiency extends to the different types of workloads and applications that it can power. Let's take a look at a few examples. Many organizations have a variety of business-critical and other applications that support their line of business. This aligns perfectly with the flexibility that vSAN provides. Run business-critical applications alongside other applications, or carve out clusters focused on specific application requirements. Whether they be VDI workloads, business-critical workloads, or common IT service workloads, not only can you easily meet the needs of the application, but the flexibility of the architecture allows you to deliver those services in many different ways. House them in a central data center, or perhaps a stretch cluster that spans 2 physical sites. Maybe an organization has several branch offices, or perhaps they want the flexibility to expand resources by using the cloud. vSAN can meet all of these demands and more, all by using a single management plane, vCenter Server. vSAN 7 Update 2 provides a rich set of cloud-native storage capabilities. Containers powered by vSphere and vSAN can easily consume persistent storage in 2 distinct ways. Containers can mount block-based volumes presented directly from vSAN. These first-class disks can be used by a single pod and can be managed directly in the vCenter UI. Containers can also mount NFS file shares served up by vSAN file services. These read-write-many volumes can be mounted from several pods and also managed directly in the vCenter UI. What's most important and potentially the most valuable aspect of vSAN's cloud-native storage capability is the connection that it provides in the control and management of the volume or disk. When developers spin up an additional Kubernetes pod, they associate a storage class to define the type of storage that should be used. vSAN automatically maps this to an associated storage policy, and the storage policy can then define the level of physical resilience and other characteristics. The developer doesn't need to know anything about the underlying architecture, and the vSphere administrator doesn't need to delegate the storage for the developer. Native file services for vSAN helps ease the burden of management when vSAN environments require file-level services. Instead of using a legacy physical storage array or deploying VMs to provide a file service, an administrator can simply enable the cluster-level service on a vSAN cluster. VMware took a very careful approach in how best to provide file services that can easily scale and support a broad variety of conditions. The file services provided in vSAN 7 Update 2 is an exciting step in that direction. vSAN File Services supports NFS and SMB that addresses the most common use cases for customers. File Services also now includes support for secure authentication methods, Kerberos for NFS, and Active Directory for SMB. Since File Services is integrated directly into the hypervisor, the administrator enjoys all of the benefits as a result: efficiency, integration, compatibility, and monitoring. Flexibility, efficiency, and performance would be easily lost if a solution were not easy to operate. vSAN offers a comprehensive management tool to help you deploy, operate, and optimize environments. VMware has used simplicity as an inspiration behind its holistic approach when looking at the deployment, operation, and optimization of a vSAN environment. Everything from day 0 deployment activities, as well as day 1 and day 2 operations, have been integrated with vSAN to drive up operational efficiency and drive down TCO. Part of this is achieved through the use of cloud connectivity integrated into several aspects of vSAN. Ensuring a flexible deployment model for a vSAN-powered environment means that all types of deployment conditions must be accommodated for. vSAN now includes a quick start, guided cluster creation, and extension wizard in vCenter that guides the user through the deployment process for vSAN and non-vSAN clusters. The vCenter UI now provides an easy step-by-step configuration to create and configure a production-ready vSAN cluster. It covers every aspect of the initial configuration, such as host, network, and vSphere settings. Quick Start also plays a part in the ongoing expansion of a vSAN cluster by allowing a user to easily add additional hosts to the cluster. For greenfield environments, the Quick Start wizard now follows the vSAN Easy Install wizard. Easy Install is a part of the vCSA installer and allows the user to easily build a brand new vSAN cluster, starting off with just a single host, and the newly deployed vCenter server living on the single node vSAN cluster. Quick Start offers the next step to complete the process of a multi-node production-ready vSAN cluster. vSAN Easy Install and Quick Start make for a complete end-to-end guided installation and configuration experience for the initial and ongoing configuration of a vSAN cluster. vSphere 7 introduced an entirely new solution for unified software and firmware management that's native to vSphere. Enhanced through vSphere 7 Update 2, vSphere Lifecycle Manager, or VLCM, is the next-generation replacement to vSphere Update Manager, VUM, and is built off of a desired state or declarative model. VLCM will provide lifecycle management for the hypervisor and the full stack of drivers and firmware for the servers powering your data center. VLCM is a powerful new approach to creating simplified, consistent server lifecycle management at scale. It was built with the needs of the vendors in mind as well. Server vendors are able to provide their specific lifecycle updates through our framework using a plugin that can easily be installed by the customer. vSAN Health is a cloud-connected mechanism integrated throughout vSAN. While it's most visible within the Health menu while monitoring a vSAN cluster, it's integrated throughout the product to provide the administrator with the latest checks and remedies for optimal reliability and performance. Health checks test all aspects of a vSAN environment and provide prescriptive suggestions on how to remedy an issue. Most importantly, VMware can provide continuous updates to this health check framework. Since it uses VMware Cloud Analytics, VMware can introduce new health checks without a need to update vSAN. vSAN Support Insight enables an improved customer support experience by proactively providing VMware Global Support Services, or GSS, data about a customer's vSAN and vSphere environment. This data is anonymized and then uploaded to VMware Analytics Cloud, where it's processed and converted to useful information, such as configuration specifics, performance, and health status. GSS can get to the troubleshooting effort faster when less time is spent on gathering the data. What does this mean for a vSAN customer? Faster time to resolution and a direct way to help VMware improve the product experience. vSAN was built to interact easily through various interfaces, whether it be through the vCenter Server UI, Power CLI, or APIs. vRealize takes advantage of the collection of APIs from vCenter and vSAN. It is this deep level of integration that allows infrastructure analytics offered by VROps and Log Insight to see the right data and provisioning automation offered by VRA to work across different types of topologies. Changes in the data center are happening elsewhere and will be a topic that you may find yourself discussing very soon. vSAN is one of the first and most important steps in preparing your data center to be fully software-defined. A software-defined data center powered by vSAN enables you to run a true hybrid cloud environment in order to accommodate the very latest demands of your organization. Before you decide which path is right for you, there are some steps you can take to learn more about vSAN and vSAN-powered HCI solutions. First, if you still aren't sure about the fit or right size of vSAN for your environment, your organization can sign up for a free vSAN assessment. This is a tool our team can help you load to get a clear understanding of your environment and some specific recommendations. Next, if you just want to play around with the solution a bit, then we have a free online hands-on lab available 24/7. This lab offers an easily accessible way of interacting with the product that requires minimal effort. Test Drive allows users to explore vSAN in a real environment, running with real high-performance hardware. This is an ideal platform for testing and POCs through an accredited VMware partner. Test Drive helps reduce the need to run on-premises testing and evaluations to help answer the customer's questions more quickly. And if you're already sold, then look into the right deployment option for you and contact your sales or partner rep to get started.